stellar space has been observed to visit our solar system. Humans have been exploring space for decades now. Normally we're the ones that go visit the far ends of the solar system and beyond to discover things that we can't with a regular telescope. The general idea is that these things exist, they are there in space, and we just have to go and find them. But with the discovery of Oumuamua, all of that changed in a jaw-dropping twist that sent shockwaves through the scientific community. Neil deGrasse Tyson brings forth the first-ever tangible images of Oumuamua, emphasizing that if we want to think about the future of civilization, we have to include a defense plan against asteroids. The enigmatic interstellar object has confounded astronomers for years. Join us as we embark on an extraordinary journey, peering into the very fabric of existence where the mysteries of Oumuamua await their long-awaited unveiling. In 2017, an astronomical event unlike any other occurred. For the first time, we spotted an object that we believe originated beyond our solar system. Its origin was once a source of controversy. Was it a comet, although with a peculiar orbit? Was it an asteroid because it didn't have a noticeable tail? Or was it something completely unique, a visitor from another galaxy, and the first instance of an altogether new kind of object? It was named Oumuamua, which means messenger from the distant past in Hawaiian, and it became a magnificent discovery as well as a glimpse into what items exist across interstellar space. But one scientist, Neil deGrasse Tyson, enamored with his own notion and ignoring the extensive study done by other experts who specialize in this subject, has gone on a public crusade to persuade the world of the most implausible explanation for this natural phenomenon: aliens. For the better part of 4 years, Neil deGrasse Tyson has been all over the media rallying popular support for a theory that defies scientific proof. Contrary to popular belief, including that found in Loeb's new book Extraterrestrial, The First Sign of Life Beyond Earth, this is not a possibility worth considering as a scientist. A simple examination of the evidence reveals why. Every object gravitationally impacted by the Sun will follow one of 4 orbital routes according to the law of gravity: circular with an eccentricity of 0, elliptical with an eccentricity larger than 0 but less than 1, parabolic with an eccentricity precisely equal to 1, or hyperbolic with an eccentricity more than 1. Prior to 2017, we had encountered a few items with eccentricities of 1 or more, but only by a little margin, values like 1.0001 or such. Even with Jupiter's help, the fastest moving solar system object yet spotted has an eccentricity of 1.06. This relates to an object escaping the Sun's gravity, although by a small margin. For Oumuamua, it was quite the opposite. It immediately became clear that this object was something special, as its eccentricity was about 1.2, corresponding to an escape speed more like 26 km per second. It was the fastest moving naturally occurring object to leave the solar system, with such a speed being a phenomenon that would be impossible from even an ideal gravitational interaction with a planet like Jupiter or Neptune, which weren't in the path of Oumuamua at any point. Clearly, it must have originated from outside of our neighborhood. By the time this item reaches interstellar space, it will only be moving at 1 km per second. Many of these objects, according to models and estimates, should travel through our solar system on a yearly basis, but we wouldn't be able to detect them unless we began taking frequent, practically nightly images of the whole sky with high sensitivity over and over again. That is exactly what the Pan-STARRS telescope has been doing for years, and it was this telescope that discovered Oumuamua. It is the first detection of an interstellar intruder. Scientists finally agreed on this label when it came to identifying this item. In fact, the only reason we discovered this one was because it got very near to the Sun, came into our solar system, went around the Sun, and flew by Earth as if it were a probe, which is unusual for an object of this type. It really traveled through Mercury's orbit, which is rarely scanned by our telescope since it's a big no-no to unintentionally risk aiming your telescope toward the Sun. It wasn't discovered until it had passed across to the opposite side of Earth's orbit on its journey out of the solar system. We discovered it when it was 23 million kilometers away from Earth. When Oumuamua was closest to the Sun, it was traveling at incredible speeds, up to 88 kilometers per second, or 3 times the speed at which Earth circles the Sun. but we were lucky to have captured it at all. It was tiny, approximately 100 meters long, dim, and bright red, comparable to the Trojan asteroids that circle Jupiter. Its color differs from that of known frozen things, failing to match comets, Kuiper belt objects, or even centaurs. Further examination showed a certain level of boredom in Oumuamua, since it exhibited no molecular or atomic absorption or emission signals. In fact, if it weren't for two peculiar characteristics of this object, there would have been little to notice about it other than the fact that it exists and follows the course we saw. The first unusual aspect of Oumuamua was discovered in October of 2017, shortly after its detection. We only had a brief window of opportunity to make follow-up studies because it was pretty close to Earth, but yet traveling away very rapidly, so a number of telescopes set their sights on this cosmic oddball. The brightness of the object fluctuated by around a factor of 15 over a timeline of about 3.6 hours, but not on a regular basis like clockwork. Comets and asteroids may differ by a few percent or even a factor of 2, but a factor of 15 is unheard of. Models of this object suggest that it is both elongated and tumbling, which would explain its frequent extreme brightness changes. This is a good explanation because unless there is some mechanism for obscuring the light from this object on one side, such as an interstellar analog of Saturn's two-toned moon Iapetus, or perhaps dust or outgassing, a change in the object's apparent size could explain the large brightness variations. It's not surprising that this thing is tumbling, but seeing an object so fully stretched like a rock that's been worn for a very long period in a river or ocean makes this object all the more remarkable. The second strange characteristic appeared as we followed Oumuamua's route out of the solar system. We thought, maybe naively, that it would follow a hyperbolic orbit, as if the only force acting on it was gravity. What we discovered, however, was that a regular, fully hyperbolic orbit did not suit what we saw. It felt as if there was an extra acceleration, as if something undetected was pushing it in addition to gravity's pull. Since its discovery, the astrophysics community has published several publications on Oumuamua, bringing together the lessons we learned and aligning our pre-existing ideas with the new findings to construct a comprehensive picture of what may be lying in interstellar space. A single object such as Oumuamua will only get this close to a star in the Milky Way once per 100 trillion years, or nearly 10,000 times the current age of the universe. So, how did we become so lucky to watch it? It's because there are so many of them. According to some calculations, there may be as many as 10 to the power of 25 bodies like this, interstellar interlopers hurtling across our galaxy. Given the huge quantity of these objects out there, they will travel through our solar system on a regular basis, up to a few times every year. We will be able to see them if we have the necessary equipment and scan the sky often, exhaustively, pollution-free, and at dim enough magnitudes. Many thought Oumuamua was a one-time event. As astronomer Gregory Laughlin described it, this was the time of Oumuamua's life. Borisov, unlike Oumuamua, has a recognizable look to us. So, what was the difference between these two objects? We must acknowledge that there might be several answers to that question. Perhaps they aren't that dissimilar, but Oumuamua was too tiny to accurately quantify with the tools we had in 2017. We spotted Borisov as it was entering the solar system, allowing us lots of opportunities to examine it, whereas we only observed Oumuamua as it was leaving. Scientists have been at war over how to explain its peculiar properties and precise origins since its discovery. Researchers initially labeled it a comet, then an asteroid, before eventually declaring it the first of its kind, a new class of interstellar objects. According to a recent report published by experts at the Harvard-Smithsonian Center for Astrophysics, the elongated dark red object, which is 10 times as long as it is broad and traveling at speeds of 196,000 miles per hour, might have an artificial origin.